Welcome to Activity 5.2, Creating an Isobar Map. So this would be a flip lesson. So you're going to go through and you're going to complete your book via this video. Now our learning target today is we're going to create a map that represents air pressure data. In other words, we're going to take air pressure data and we're going to create an isobar map with it. So the expectation before you leave today is that you complete Activity 5.2. Now if we back up a little bit to Activity 4.1, in my book it's on page 34, so it might have been on a different page for you. But the important thing is in Activity 4.1 we took a look at air pressure. However, when we looked at this air pressure, we measured it in inches of mercury. Now there is another unit of measurement for pressure, and it's called the millibar. The value on the map we're going to be using today are in millibars. Now millibars are usually used to draw isobars using increments of 4 millibars. So for example, if 1,000 millibars is the starting point, therefore if we go by fours, if you start with 1,000, the next one would be 1,004, then 1,008, then 1,012, and we could also go down. So if we started with 1,000 and we went down, it would be 996, then 992. So again, we could go up by fours, we could also go down by fours. So here are the procedures. So we're going to go through these and I'm going to get you started on this activity. So in class you learned that millibars are a measurement of air pressure. And what you're going to do is you're going to use the following map and complete steps 3 through 5. So use a pencil to lightly draw lines connecting identical values of air pressure. So find the 1024 or the 1024. So you can see that it's over near Utah, and well, it's actually in Utah. And in my book it's, Utah is shaded and it's dark colored. So what I want you to do is put your pencil on that 1024 reading. And then what I want you to do without lifting your pencil is draw a line over to the next 1024 that you see. And then what I want you to do is take that pencil, keep it on the paper, and then draw a line to the next 1024 millibar that you see. And I want you to completely connect all the 1,024 millibars. And remember, isobars are smooth lines with few bumps. They're not going to be really jagged. They're not going to have sharp turns. So what I'd like you to do is pause the video and draw in your 1,024 millibars. And I'm going to demonstrate in a few seconds how to draw that in. But again, please pause the video and I'd like you to try it first. Alright, so here we are again. And so here's a map. So if I was drawing in, here's the one that we were talking about. So this is Utah. So if I put my pencil here, and I'm just going to connect all these 1,024 millibars. Now the next set of directions say repeat this procedure with the next isobar value. This is 1,020 millibars. Be sure that your isobars do not cross each other. Continue with the remaining values until you have each of the remaining values connected with an isobar. So go ahead, pause the video again, and finish connecting all of them. And then I'll go through it with you just to make sure we're on the same page. Alright, so you've had a chance to draw yours in. So let's take a look. So if I look at the next one, it says down here go to the 1,020. So I can quickly draw these in and I can see all the 1,020s. Again, I'm trying to make sure there's no sharp edges. There's few little bumps in them. So when I look over here, I can see there's 1,016 on both sides, but I'm just going to connect these three. I don't have the information here, nor do I have the information in Canada. So here I'm going to come around, I'm going to find 1,016, but watch this. I can see it coming all the way up here, and I'm going to stop again because I don't have any information up here. I don't know how far it goes up. So I go to the next lower one. Again, we're going in increments of 4 millibars. And then here's my 1,008. So how did you do? Were you able to draw all those in? If I go to the next slide, this is what I see on the key. So did yours look like that? If they did, great job. If not, erase what you have. And again, this is why we need to do our work in pencil. Erase what you have and make sure yours looks like this. You have a good example for when it comes time to study for the test. So we've just completed part 1. So let's take a look at part 2. So you have your isobars in your map. Now, the next set of directions are going to have you do four things. One, it's going to have you label with a large blue H, so with a blue pencil, a high pressure system. And so where do you think the high pressure system is on the map? And then in red, label a large L where you think the low pressure system would be. Then number three, what it wants to do in green is shade in areas where you'd expect to see rain or snow. Now remember, low pressure areas usually have precipitation because as the warmer, less dense air rises, the water vapor condenses, forms clouds, and causes precipitation. And then finally, it wants you to do a fourth thing. On your map, shade in yellow where there's areas that you would expect to see clear skies. And again, if you have high pressure areas, it's usually clear, it's usually dry because the cooler, denser air sinks and has less moisture in it. Now, if you don't have a blue, red, green, or yellow colored pencil, that's fine. Just with a large L, label your low. With a large H, label your high. And then where you see, so for example, here you see yellow, shade in yellow, the areas where you'd expect to see clear skies, just maybe draw a dashed line and label it as clear skies. And then label where you would expect to see rain. So go ahead, pause the video, and what I'd like you to do is draw those in. Alright, so you've taken some time to draw those in, so make sure you have them in before you go back to this. So here's what your answer key would look like. And again, don't worry about the page number. I understand that your book is slightly different than my book, or at least for some of the class periods. So here's where I'd have the H for the high, the L for the low, and here's where I would have my green because this is where I'd expect to see the cloudier skies, and here's where I'd expect to see the clearer skies. And again, this is not perfect by any means. It just gives you a rough idea of where everything is. So if we go to the next slide, which is right here, what is the difference in pressure between the center of high and the center of low? Now, this isn't one of the questions in your book, but could you answer this? So if I asked you this in a test, would you be able to do it? Well, just remember, you've got the measurements right here. So that 24 really means 1,024, and this 8 really means 1,008. So if they want you to know what's the difference, well, just subtract them. So when I see difference, I always think subtraction. So this should give me 16 millibars. Now, do you think that's a large or a small change? Well, you don't have a lot of experience with that. But if this is all we have for the entire country, just one high, one low, and there's thousands of miles in between, this is a pretty small change, which means you won't have much for winds. So when I look at the next slide, look at the distance between the isobars, between the high and the low. Are they close together or far apart? So you notice that these were far apart and you only had a 16 millibar change. That tells you if they're far apart that there's not going to be a very strong wind. If, for example, you had lots more millibars in here, and say this wasn't a 16, but maybe it was 1,000, what, 16, 12, 8, say 1,004, and then you had a whole bunch more millibars, then the wind would be stronger. So if we go to the next slide, do you think there will be a strong wind? Why? Draw the wind directions. So we already answered the first part. Do you think there'd be a strong wind? No, it's not much of a change. Now, here, let's practice drawing into wind directions. Now, in class, we've talked to you about this, and we've made the comment that things always go from a high to a low. However, it's not quite that easy. We also have this thing called the Coriolis effect. Now, because the Earth is spinning, wind will get redirected to the right. So instead of this wind going perfectly towards the low, it actually gets deflected off to the right. So if wind was coming, say, from over here and was going towards the low, if I was standing here, it would have to be deflected off to the right, which is to this direction. And if I was down here, it would be deflected off to the right. And these are just rough drawings, so again, they may not be perfect. So this wind would actually be deflected off to the right. So if you've ever kicked the ball or thrown a football and it's really windy, you notice how when you kick it or you throw it in the air, it actually goes off to one side. That's basically what the Coriolis effect does. So if I was over here on this side, things would be deflected slightly to the right. So depending on where you are, the wind is going to be changing directions. As these lows and highs move around you, they will be changing directions. So if I was standing here looking this way, again, things would be deflected to the right. Now if you notice there's a pattern, these are all going in this direction, right? So what direction is that? That's counterclockwise. But if you look at these over here, you should notice that they're actually going clockwise out as you move from the high. Now again, this is just two-dimensional. Remember, in the high, you actually are going to have your air descending as well. So it's not only going to be moving out and to the right towards the high, it's actually be coming down because the air is going to be descending, where over in the low, the air is rising. So let's look at the next slide. So remember, you have your high, and in general, you have a clockwise flow. You have your L. This is your low. It flows counterclockwise, roughly anyway. So let's get back to the questions. And here's one of the things that we'd like to take a look at. Why are the spaces between the lines not equal? Well, remember, air pressure changes depending on the temperature and density of the air. So it's not always going to be equal. And that's why you have some of these bows like you see down here. And it's not perfectly circular in nature. So here's the map I was telling you about earlier. So you see how there's multiple lows and there's multiple highs. So rarely do you see one high and one low over the country. Normally there's highs and lows all over the place. Now, why do the L's appear where there are more clouds and the H's appear where it's clear? Well, we've already gone over that in class. Remember, low pressure areas are warmer and contain more water vapor. As the air in a low pressure area rises, it cools and the water vapor condenses. Precipitation usually occurs in the areas of low pressures. Areas of high pressures are cooler and denser. They contain less water vapor and they form fewer clouds. They usually indicate fair weather. So when we look at this map, that's why right here, where you have these H's over here, you tend to have fewer clouds. Now, is it perfect? Absolutely not. So you see there's a few clouds here and clouds are starting to roll in. So it's not perfect, but in general, where you have your stormy, rainier weather, you're going to have your lows. Where you have H's, you're going to have more clear weather. So I went one too many slides. So let's get back to your book. So if you look, there are some making sense questions. So go ahead and finish the making sense question. So let's pause the video right here and restart it when you're done. All right, so you've had a chance to look at the question. So let's go through the answers. Look at the low pressure area on your map. What is the pressure reading at the center of the low? Well, you should have saw that it was 1,008 millibars. What is the pressure reading on the next isobar? Is 1,012. So fairly simple questions. Why do you think this is happening? Or what do you think is happening to the pressure between those isobars? Well, it shows that the pressure is rising and it's going up. So how did you do on those questions in today's activity? Pretty good. Now, open to the front of your book. We're going to add two scientific principles. Air masses move when high pressure air pushes into the space of lower pressure air. At the surface, higher differences in pressure over small distances results in stronger winds. So when we talked about the isobars, if they were really close together, you tend to get stronger winds. If they're really spaced out, you tend to get less strong winds, or winds that aren't nearly as fast. So go ahead, pause the video if you haven't written this all down yet. Okay, so here is the last scientific principle. Air masses move when more dense air slides underneath less dense air, causing the less dense air to be lifted upward. This less dense air is unstable as it's forced upward. It transfers energy to the surrounding air and cools as it rises. So when we go through this, air masses move when more dense air slides underneath it. So that's what causes the weather to move. That's what causes the systems to move around. That's what gives us our weather and why it's different from day to day. Now, this less dense air is unstable, and that's talking about the warmer, less dense air, because it's going to be forced up and over the colder air that comes in. And this is where you get your instability. This is where you get your storms. So this was a flip lesson. So hopefully everything went well. And if you have any questions about anything that you covered in lesson 5.2, make sure you ask me in class.